Hi good people, Titus here for another Unreal Engine tutorial, and in this video we're going to create a grid system using square tiles. This will be a two-part series, and in part 1 we'll create the tile layout, and in part 2 we'll create the grid color and movement code. Let's not waste any time and jump right into it. Okay, we're going to be working in the top-down template. I think starting off we're going to make some adjustments to the existing code. So in the top-down folder in Blueprints, let's open up the BP top-down character. We're going to select the spring arm in the components tree. In the right-hand side details panel, we'll set the rotation to be -90 degrees. And then we'll scroll down and select the camera lag speed. We'll increase it to 1, which will basically increase the lag, so lower the value to 1. And then the other thing we want to change is the camera. We'll select the camera in the components section. And we're going to set the projection mode from perspective to orthographic. For the ortho width, you can simply set that to 2048 by multiplying it by 4. We can compile and play this, and we have a nice, simple top-down example. And now we simply need to work on our grid. Coming back to our main scene here, we can go to the content folder, right-click, and create a new blueprint class. We're going to use the type actor, and we'll call this BP_grid. We'll double click to open this up, and the magic that's going to make this work is the procedural mesh component. So we're going to add 2. So we'll search for procedural mesh. The first one, I'm going to append the word lines underscore at the front. I'm then going to select the BP_grid and add a second component, and also search for a procedural mesh. And this time I'm going to append squares underscore. The reason I selected the BP grid is so when I added the component, it doesn't nest them underneath each other. They should be separate. The procedural mesh node, basically what it does is you define vertices and you define triangles, and from that it can basically draw a static mesh. So if you're unaware, in most 3D rendering software like Blender or Maya or what have you, you can render a static mesh without triangulating it, because all it's doing is rendering. But if you bring that same mesh into a game engine, typically there's going to be physics, which involves, usually like trigonometry or vector math, and that usually requires triangles. So that's why it triangulates your mesh for you. So the way we're going to do the grid is we're going to tell the procedural mesh to draw a bunch of lines, both vertically and horizontally. And then for our selection, we're going to draw a square in the center of the lines. So we're going to have to define some vertices and triangles for that to work. But yeah, we got the components set up, so let's define the functions we're going to be using. The first function is going to be a draw line. And then the second function we're going to use is we'll do line width, and then we'll do line height. Now for the line height and the line width, these are going to be pure and const functions. You can think of a constant function as a read-only function that won't modify the object it's called from. There's a few reasons to do this, mainly code safety. You won't unintentionally modify a variable that you didn't want to. And you get some small compiler optimizations that become available in some engines with this. But marking a function pure actually changes the blueprint node that it's actually called from. So as an example, we did this on line height. So if I go to the event graph and I make a call for draw a line, you see we have execution pins on this one, but if I do a call for line height, you see it's just a regular function. So it actually does change the node when you mark it pure. So just a heads up on that. But yeah, so we got line height, pure and const. We will want to set it to a private access specifier. And then for the category, I'm actually going to create a new category called private, just to organize my functions a little bit easier. For the line width, this is going to be the same. It needs to be pure, it needs to be const, and we'll set it to private, and I'll move it into the private category. so it's easier. The drawOn function is actually just going to be marked private and moved in the private category, but I am not going to mark it pure or constant because it is going to be modifying several variables. All right, and now that we have the functions created, we can probably work on creating our variables because there is quite a bit. So the first variable you probably can guess is going to be rows. We need rows and columns to make a grid, right? We might as well just use an integer. And then we're going to make some adjustments in the details panel, and then we're going to duplicate this so we don't have to make those adjustments each time. The first one is it should be instance editable, blueprint read only, expose on spawn, and private. Basically those 4 should be good. Now if we right click and duplicate, it keeps all those same settings, and we can just rename the variables that we need. So we need rows, we need columns. Those are both going to be integers. We also need tile size. This one, however, will be of type float. And then we also need a line thickness. And that will also be a float. And then while we're here, we're going to be doing the color stuff in the next video, but we might as well just create the variables for it now. We'll do a line color. This one's going to be a weird type. You're going to have to search for it. It's actually linear color. Linear color. And then we can actually duplicate that one. And this one is going to be the square color. Because remember, we're drawing lines and squares. And that will also be a linear color. And then the next 2 variables that we need are going to be a line opacity, which will be a float. And we need a square opacity, which will also be a float. And I believe this should complete all the global variables we'll need with this blueprint. We're going to create some local variables as well on each of the functions, so there'll be more work to do there. But this pretty much sets up the, and if you get this error, just, I think if you hit compile again, it goes away. I don't know why it does that. But yeah, so we should be pretty good with this. Let's go ahead and start working on defining or writing some of our functions. The first one we'll do the easy ones. So we'll start with the line height. So you can click line height at the top here. To get the line height, we can just simply use columns. So hold Control, drag columns in, and then you can pull this into a multiply node, and we can multiply it against our tile size. And then we basically are going to return this value. To be able to return it, we need to select on line height, and there is an output pin on the details panel. You hit the plus sign, and then you can give it a name. We'll call it width, and you have to match the type. So returning a float, so we'll set it to float, and then we can just pass this in like so. And this completes the line height function. Let's go ahead and write the line width because it's pretty easy as well. It's the same thing, just instead of columns, we're going to be using rows. So we'll hold Control, we'll drag in rows, pull into a multiply. We'll multiply it against our tile size, and then we need to return this. So you might actually be able to drag this into here, and it will create the return node for you as well. And I'm just going to call this height. It sets it as a float, so I can just pass this in like so. Now the draw line is going to be a heavy hitter. That's going to be probably the bulk of this video. Real quick though, let's define some of these variables so they're not all 0. So I think for the default rows, we'll set it to 10. Default columns, we'll set that to 10. The tile size, I'm going to try 100. For the line thickness, I'm going to set that to 10 starting off. Line color, I'm going to leave alone. Square color, leave alone. Line opacity, I'm going to set to 1 for the line, and for the square, I'm going to make that a little bit see-through at a 0.25. All right, let's move into the draw line function. And this will be the most confusing one. It has a lot of input pins actually. So we'll click on the draw line, and in the details panel, you can hit the plus sign to add an input pin. The first one we'll add is going to be a start. It's going to be a vector. So basically the start of the line. And we also need the end of the line, which is also a vector. We also need a thickness. And then we'll set that to an actual float. And then we need some oddball ones. We're going to need some vertices and some triangles. The vertices are going to be a vector, but it's going to be an array. So we'll set this little icon right here to drop it into an array. We'll hit the plus sign to add in the triangles. This one we can just set it as an integer, and it does need to be an array as well. So this will basically complete our input pins. Now when you define an input pin on a function, you can simply drag that into an actual node, but another way you can do it is you can right click and do get and then the name of the node, so get start. And this is basically the same as this. I can also do that for triangles as an example. So starting off, we're going to need a sequence node, so we'll hold S, click it in the graph, and that'll give us our sequence. And we can hook up our execution pins like so. We can then right click and get thickness, which is going to be a reference to this input right here. We need the half thickness to be able to calculate a direction. I'm going to collapse the global variables, and we're going to be working in the local variables. These local variables will only be seen inside this draw line function. So if you move over to line width, you will not see them, or if you move into construction or event viewer, you will not see them. So we'll hit the plus sign here, and we will create a half thickness, and it will be a float. And then I can hold the Alt key, drag into here, and that brings a setter, and then I can hook up the execution pins like so. And then to generate the half thickness, you probably already guessed, we can just take the full thickness into a divide node, simply divide it by 2, and then pass that value in here. Calculating direction, which is the next thing we need, is going to be a little bit trickier. So we'll hit the plus sign to add another local variable. We will call this direction. Now a vector direction is obviously going to be a vector, right? So we'll set the type to vector. We can hold Alt, drag this into here, hook up the execution pins, and then we need to figure out how to actually calculate this. The way we can do it is we can use the start of the line, subtract it against the end of the line, and then we'll want to normalize that to account for any negative values. And then we can multiply that against a vector that points straight up. So grid systems typically an XY, and if we use a line pointing straight up, we can use the cross product, which will create a resulting vector that is perpendicular to those two vectors. So if we have one vector going straight up and then another vector, we don't know where it's going to be going because it's going to be generated through the construction script. That'll basically give us the direction that the line's going. So let's go ahead and right click, do get end, and then drag out to the bottom. There's the get end, which is the same as this right here. So we can take the end of the line, we can subtract that against the beginning of the line, or get start. We can then normalize that. And then off that vector, we can do a cross product against another vector. We can use 0, 0, 1, which is basically just a vector going straight up. That will basically get a cross product between any two vectors, will generate a vector that is perpendicular. So that'll basically give us our direction here, which is what we need. All right, so that completes our first sequence. The second sequence is going to be handling the vertices and triangles, as you could probably already guess, because that's the only thing kind of left to do. What we can do is get triangles. Now arrays, you have to define their size, so we can add elements or reappend elements to the array. So pull off this into an append array. And then from here, we can do get vertices. And then we can do the same thing and call into an append array. And now we just need to basically feed these append values to build up the triangles and the vertices. So I think to do this, let's actually work on the vertices first. And I think before I do this, it may help to maybe show, can I compile? No, I can't. I can disconnect this and that should let me compile. All right, so let's go to the event graph and we'll take a little bit of a detour. You do not need to follow along with this. In the begin play, I can call into a create mesh section. So we have this create mesh section. We need to reference a procedural mesh, so we can use the lines or the squares, doesn't really matter. I will use the lines for this example. Again, you don't have to follow along with this. I can pull off the vertices and promote it to a variable here. And then I can pull off the triangles and promote that to a variable here. I can then select this variable and I can make it instance editable, show 3D widget, expose on spawn, and I think that's fine. Triangles, instance editable, expose on spawn, and I think that should be fine. So now I can compile and save. And if we go into the world, let's throw out our grid here. And you can see we have some vertices and triangles here. So say I want to make a square, like a line is basically a rectangle, right? So let's add 4. So add 4 vertices right here. Now the first vertice I can leave at 0, 0, 0. The second one, let's say I move it 200 units over, and then the third one I'll move 200 in the Y, and then this one I'll move 200 and 200 over in the X and the Y. And you can see these vertices are making a little square. That's great. If I play, nothing's going to really happen. You're not going to be able to see anything because we haven't defined the triangles, because it doesn't know basically how to connect these dots. If we add, now a square is going to have 2 sets of triangles, and each triangle will have 3 vertices. So we're going to basically need 6 elements for the triangles. So there we go. Now, when you're doing the triangles, you basically have to define the numbers to use, right? So we can see in the world, we have 0, 1, 2, and 3. I'm going to create my first triangle by going 0, 1, 3, and then back to 0. So 0, 1, and 3. And then my second triangle I can create by making 3, 2, 0, and then back to 3. So I can set this to 3, and then 2, and then back to 0. So now you can see we have a square. Pretty neat, right? So you may be wondering, does the order matter? Yes and no. The reason it kind of matters is, I'll give you an example. If I reverse these orders, like say, so on this one I did 3, 2, 0. Let's actually go 2, 3, 0. So 2, 3, 0. This one on the left isn't going to render, and you can see it's here. But it actually is rendering. And maybe I'll play some B-roll footage here to kind of demonstrate this, because it's easier to see in Blender. But when you draw a static mesh, you have these things called normals, which are basically like an optimization trick that a lot of engines use. They'll only draw one side of an object. It doesn't matter if it's a plane, a sphere, a cylinder, whatever. It's only drawing, normally you draw the outside portion because that's the part you see. But if you're modeling, you could flip, or what's called inverting the normals. So you draw the inside faces and you don't draw the outside faces. And that's kind of what you're seeing here. Is it's not drawing the top side, but it's drawing the bottom side. So if I had a way to flip the camera upside down, looking at this from the bottom, you'd see that other triangle, but you wouldn't see the one triangle that's showing now. So basically when you're doing this, it doesn't matter how you do it. You can line up your vertices, however you want. The important part to note is if you order them counterclockwise when you're defining your triangle, the normals are going to be pointing up, meaning that if you're looking down from a camera, you're going to see it. But if you order them clockwise, they're going to be facing down, meaning the camera is going to have to be under the world to be able to actually see it. So just, kind of be aware of, depending on the mesh you're drawing, however you're drawing it, order it. If you want it to build a view, where the normals are facing up, or you want to be able to see it when you're looking down, you want to use a counterclockwise rotation. But that was enough of a detour. Let's go ahead and head back, and let's delete this here. If it'll let me, because it's saving. All right, and then we will delete those two variables. Hopefully that kind of made sense, but let's actually get back to, and I'm gonna reset this to world origin over there. Yeah, that looks fine. Okay, and let's go back to the grid. Okay, so I'm going to hook this pin up, and that of course did delete my variables. Get triangles, pass that in here, and get vertices, pass that in here. Okay, so let's define our lines, our vertices. We're going to be basically making a box, is the best way I can think of it. So we have our local variables here. We're going to need, we're going to be using the direction for a lot of this, but we're going to be needing our start. And we're going to need the end. And then we can hold control, drag in direction. All right, and then we'll also need the half thickness as well. So basically what we do is we take direction, we multiply that against our half thickness. And that is kind of the secret sauce for all the points. So we're gonna create 4 points, right? So I'll need this 4 times. Control C, and we'll do Control V, that'll work better. Okay, oops. All right, so now on the first vertex point, you can use the start location, and we can pull into an add node, and we're going to add these 2 values together. And then we're going to pull into a make array. And that's our first element. We're going to hit the add pin because we're making a box, remember? And our box is going to have 4 points. So this one will be our first point. Now, if you think about this logically, we're basically saying, take the direction, multiply against the half thickness, and then you're going to take the start of the line and add it to this, and that's going to give the first value. So what is this actually saying? Well, this is going to be the top left corner of the box. So the next point, we can take our direction times our half thickness, and we can take the end of the line, and then we can add these together. And then what this is saying, move it down a bit. So you take the end of the line and then you add it to the direction times the thickness. That's of course going to be the top right corner. Oops. All right, and then we got the third one here. We're gonna borrow the start again, and we can Control D. I don't know why that's not working. Control C, Control V. So we can pull into, and instead of an add, we can subtract. So we'll take these two values and we'll subtract them this time. So what does that give us? Well, the first time when we added them, we got the top left corner. So now we're subtracting them. Probably guessed it, right? We're getting the bottom left corner. All right, and then we'll pass this in here. And then we have our final one. I will grab the end, because it's basically going to be the end subtracted against this result, which of course, as you probably process of elimination, this will be the bottom right corner. Then we can pass this into our array here. So you can copy my code and do it exactly like I am doing it, but it doesn't actually matter. The important part was what I was trying to demonstrate earlier in the vid when I was making those triangles. You can define your box or your mesh however you want. The important part is you need to be able to realize that, you know, if the camera's going to be in the air facing down, you need to align these vertices in such a way that you're going to remember where they are, so you can create the triangles in a counterclockwise fashion. Or of course, if you happen to be creating a mesh in the air and your camera's going to be on the ground looking up, you would want to organize the triangles in a way that is clockwise, so the normals are pointing the right direction. So that's kind of the point I was trying to demonstrate earlier, but I know it's a little bit confusing. All right, so we can pass this array in here, and this completes our vertices. Now that we have our vertices, we can define our triangles. So basically what we want to do is just right click and get vertices. From this, we can pull into a length function here. Which basically just returns an integer value. And then we can pull into an add node. And then this is going to be basically us telling the code where to place the vertices to actually draw the triangle out. So I am going to pull this into a make array. Now remember when we did the triangle in the world, we had a box will have 2 triangles in it, and each triangle has 3 vertices. So 3 times 2 is 6. So our array is going to have 6 elements. So we'll click the add pin until we get 6 elements here. And then effectively what we need to do is, I don't know why it's not working. Control C, Control V. We'll just Control copy paste 6 of these. Like so. And the values that I'm going to be using based on the square, which I think I had some math here. So this is the square that we created based on my code. So we're basically going to be going two. You can use any order. I'll give you the order that I'm using. Basically, the first one's 2, 1, 0. So again, I am counterclockwise. And then the second one is going to be 2, 3, 1, which is also counterclockwise. Now you could, of course, just go 3, 1, 2. That's counterclockwise. That works too. Or 1, 2, 3. That'll also work counterclockwise. So any value that actually produces a counterclockwise triangular movement will work. So that's the important part. So this one was 2. This one was 1. This one was 0. And then the last one was 2, 3, and 1. And then I'll hook up these pins here, like so. Then we can pass this array in over here. All right, and that pretty much completes this function, which is, I think, the hardest part of this tutorial, I think, is pretty much all this. So if you got this far, you're doing pretty good. Now we basically need to figure out where we're going to be calling all these functions. You could do it in the event begin play if you wanted it to be kind of like real time. It's going to be a little bit of a performance hit. I find it's better to do these things in construction scripts. Just do it before the game even launches. That way it's more optimized at runtime anyways. So you want you'll notice a slower load time when you like launch the level. But once it's up and running, you're pretty much good, and you're not going to show any issues. So I'm going to head over to the construction script, and we're going to begin working on the code for this one. Let's minimize our global variables here. We're going to need some local variables for this one. So we'll hit plus sign here. The first one's going to be a line start, which is going to be a float vector. The next one will be a line end, and then we need some line vertices and triangles, and we might as well set the square up as well, because we're going to be setting those up in the next video. So go ahead and create a line vertices. That will be, of course, a vector, and when you select this, go to the details panel and make sure it is an array. And this will be line triangles. And then this one will be square vertices. And this one will be square triangles. Now the triangles we're just going to set as integers. The vertices we will use as vectors. Now remember, we have 2 procedural meshes. We have one that's going to be creating the squares, which is basically what we're going to use to highlight which tile you want your character to move to. And the second one is what's going to be drawing the vertical and horizontal lines. So that's why we have 2 sets of them, basically. All right, with that set up, let's work on, we're going to need a sequence node. So we'll hold S, click in the graph, and our sequence will need 4 pins. But we're only going to be working on 3 pins for today. Let's work on the first part of it. So what we can do is we'll expand out our global variables, and we're going to get our rows. We're going to be working on the horizontal lines first. So let's hold Control, drag this in here. We'll pull this into a for loop. And then after that, we're going to need to set the line start. So under our local variables, we can hold Alt, click and drag, and bring that in like so. We can take the index of our row, and we can multiply that against our tile size that we're using. And then we can pass that resulting value into our line start. Then we need to define our line end. So with the line end and the local variables, we can hold Alt, click and drag. It'll pull us into another setter. And we have a handy dandy function to actually calculate this value. It is called line width. And this was the one we defined earlier. So we can take that value and just pass it in here, and that's good. Now the final function we're going to call for the horizontal lines is the draw line function. Now we have our start and end. What we'll want to do is actually split these, because because we need access to the individual X, Y, and Z components, although we aren't using Z in this example. So to actually set this up, we need our line start. So we'll hold Control, drag that in here. We need our line end. We need our line thickness. Then we need our line vertices. And then we need our line triangles. Now a lot of these should be easy to fill out, right? Triangles go into triangles, vertices into vertices, thickness into that thickness. So look pretty good there. The line end and the line start are the confusing part. So for the horizontal lines, we're going to be drawing those along the x-axis. So we will start at the start x and at the end x here. For the line end, we only need to plug this into the end y. And that's it. This pretty much completes the entirety of the horizontal lines. So what we can do is highlight this. And I'm actually going to duplicate it first. So Control C, Control V. Because the vertical lines are going to be similar. We just have to switch some things over. So let's go ahead and comment and horizontal lines. So for our first sequence pin, I'm going to hook this into here, double click, add a reroute node, and pop this up like so. Okay, now for the vertical lines, we don't use rows, so we will delete that. And we're going to instead use columns. So we'll hold Control, drag that in here, and hook that into the last index. And I did notice a mistake here. The rows should start at 0. So we'll want to hold Control and put that into the last index there. So we're still doing the same math though. We're taking the column's index value, multiplying it against the tile size, and then we can set the line start based on that. But we don't need the line width anymore. What we need is the line height. So we also created a handy function for that. That's this one right here. And we can just drag the resulting value, and that'll take care of that portion for us, just like that. Now the draw line is also, it's the same function, but it's going to have different connections, right? So because we're drawing the vertical lines, our line start doesn't begin on the x value. It actually begins on the y. So we can take our line end and hold Alt, break that connection. And under the line start, we can hold Control, switch this into the start y. And then for the end x, we'll hold Control and plug that into the end y. And then for the line end, this is actually going to go into the end x. And then everything else, thickness, vertices, that all remains the same. And this completes the code for creating the vertical lines. So we can comment this, and we'll just call it vertical lines. And then we'll plug the execution pin in for then 1. Now notice in the viewport, nothing's happening yet. So let's go back and finish the construction script. We're pretty much close to the end here. So the last portion of this is the actual creating the mesh section, which is what I demoed just a little while ago when we were making those triangles. So what we can do is we can we can just drag in the lines procedure, pull into that for the create mesh section. And then you'll notice we have some pins for vertices, triangles, as well as normals, UVs, which we won't have access to, which is why we have to be careful when we're defining those, so we can basically tell it, where the normals are facing. But under our local variables, we have our line vertices. So we can hold Control, drag that into vertices there, and then line triangles, hold Control, drag that in there. And now, with that, we can hook in our third execution pin. And then if we compile, you'll see magically, we have a grid. Now what's neat about it is if we save and go back to our world map, we can see the grids right there. And if we select the grid, you'll notice we have the properties showing on the right-hand side here in the details inspector. You can set the number of rows, like say I do 50, and then we can set the number of columns to 50. And then you notice you get, your basically expandable tile size there. You can bump this up just a bit. And then you can also adjust the tile size, like say you did 200. It's a little bit bigger. And you can adjust the thickness of the lines to be however you need. It's pretty versatile. You got some options. Like I said, this is just part one of the series. In the next part, we'll tackle some of the code to give it some color, and also the movement code, so you can actually move around in the grid and actually select something. So right now it's kind of bare bones. It's not quite set up yet, but I think we're going to probably stick with a tile size of 100, because I think that actually matches. It's probably not lined up right, but we'll get that in the next one. But all right, everyone, put the video here to keep it somewhat short, but thanks for watching. Consider subscribing, and we'll see you on the next one.